Good morning friends. Today we are gonna see new topic in vectors, that is addition and subtraction of vectors. Okay, let's take two vectors. Let's say this is vector A and this is another vector B. And suppose if I'll ask me to add these two vectors, what should I do? There is a different methods to solve this type of sum. Number one, first one is triangle law of vector addition. Triangle law of vector addition. What the triangle law of vector addition says? Whichever two vectors are given to you, you can adjust them like two adjacent sides of a triangle taken in order. Then resultant of these two vectors is a vector which is drawn from starting point of the first vector to the end point of the second vector. I'll explain it again. Let's say this is one vector A which I have drawn here, right? Now this is vector B. We have right to shift this vector B parallelly anywhere in the given plane, right? So I'll do one thing. If I'll draw this vector anywhere in this plane parallelly, I'll get the same vector. So I'm getting arrangement like this. Whenever these two vectors are arranged in this case, it's like one after other, then their resultant is a vector which starts from first point of the first vector to the end point of the second vector. So is it okay if I write C? Yes. So I'll write it here. C is a vector addition of A and B. I'll explain it again. I have two vectors, vector A, vector B. First thing in vectors is you can shift vectors parallelly anywhere in the given plane. So I'll shift this A over here and I'll shift parallelly vector B over here, right? And I have arranged these two vectors like they are taken in order. Taken in order means wherever once will get over, we'll start another vector from that point itself, right? So A and B are in order. Then C is a resultant of vector A and B. Let's say, suppose if I'll draw vector like this. This is vector A and vector B, right? And if I'll draw this vector C like this, is it okay if I say vector C is equal to A plus B? No. Why? Because A and B, resultant of A and B should be a vector which should start from here itself, right? And you can look at this vector, this has started from here, right? So this is not a resultant of A plus B. Am I clear? Okay. Now I have explained the triangle law of vector addition. Let's say you have given me two vectors, and if I'll ask me, ma'am, two vectors are given, A and B, you calculate the resultant of that and you just tell me the magnitude and direction of that resultant. I won't be able to answer. Why? Because this triangle law won't be able to give you magnitude and direction of the resultant vector. Unless and until there is only one possibility. Let's say you have one vector like this, right? I'll say this is vector 3, right? And I have another vector like this. I'll take this another vector as 4, right? I'm talking about the magnitude of two vectors and they are arranged in order. Then the resultant is a vector which starts from the first point of the first vector to the end point of the another vector, right? So if I'll check it here, you can see that this is right angle triangle. So it's very obvious I can use Pythagoras and I'll be able to calculate here. It's 5. How come? It's under root 3 square plus 4 square, which is equal to 25, and we get 5. So in this case only, I'll be able to find out the resultant or magnitude of resultant and direction, right? Other than that, in any of the case, we won't be able to calculate magnitude of resultant and direction with the help of triangle law of vector addition. Then, what is the answer for this? Suppose two vectors are given and you need to calculate the magnitude and direction of the resultant of two vectors. Then what to do? Once again, I need to clear one more thing. Suppose if I am taking two vectors and I am going to add them, right? I will be using three words like either sum of two vectors, net of two vectors, or resultant of two vectors. All these three words indicate the same, that is vector addition. Once again, I will repeat. I said addition of two vectors is nothing but resultant of two vectors, right? It is nothing but net of two vectors, or it is nothing but sum of two vectors, right? I can use any word out of these three, right? We'll proceed to the next option. Let's say now I won't be able to calculate the magnitude of this vector, resultant vector with the help of this. So I'll be having some another option. Definitely we have, and that another option is nothing but second law, that is parallelogram law of vector addition. I'll explain it here. What is the parallelogram law of vector suggest? This is parallelogram law of vector addition. Now again I am going to do the same thing. I have two vectors. This is vector A and I have this another vector B. Now what I am going to do is I'll arrange these two vectors so that they'll start from common point. Try to understand what I am saying. I am saying A and B, you have to arrange these two vectors in such a way that they should start from common point, right? So let's say this is vector A and this is vector B, right? This vector A and this vector B. I'm just writing the magnitude of vector A and B over here, right? And angle between them is also known. Let's say it is theta. Now what you are going to do is, or what that parallelogram law says, parallelogram law says that whenever two vectors are adjacent sides of incomplete parallelogram, then the resultant is a diagonal of parallelogram which starts from their common point. Again I'll repeat, I said two vectors are given and those two vectors are arranged in this way, like the starting point is common, right? In that case, the resultant is a vector which starts from common point, but that must be the diagonal of the parallelogram. I'll show it here. Let's say I'll complete this parallelogram first, like this, right? As I said, it's okay even if I'll shift this vector parallelly anyway. So I'll shift it here. I'll make this vector B, like this, okay? And now this vector is A. This vector is A, parallelly I shifted it here, again I'll be getting it's A, right? Now this is the diagonal. There will be two diagonals of a triangle. One is this and another one is this, right? I don't want this. Why? Because that diagonal has not started from their common point. Are you getting my point, right? So we'll be considering a diagonal which should start from their common point. So I'll be considering only this, right? So I'll check this as a R, right? Now what I'm going to prove is, first of all, R is the resultant of A and B, and if R is resultant of A and B, then what is the magnitude and direction of R? I hope task is clear to everyone. Once again I'll repeat, I said I have two vectors, I have arranged them properly, right? Now I have completed the parallelogram, right? And now what is my task? I'm going to prove that R is the resultant of A and B, then what is the magnitude of R and what is the direction of R, right? So let's start. When I'm saying this angle is theta, right? I'll extend this vector A like this. Again this angle becomes theta. Now I'll drop one perpendicular over here like this, right? Now this is B, this is A, and we have this angle is theta. So look at this small right angle triangle. I'll use some another ink. Look at here. Let's say I have this small right angle triangle, right? What do you have here? It's B cos theta. Why? Right angle triangle, this is the adjacent side and this is the hypotenuse, right? So adjacent by hypotenuse must be equal to cos theta. So this side becomes B cos theta. What about the opposite one? This is B sin theta, right? Now look at this big right angle triangle. Big right angle triangle. This is hypotenuse. This is one side, A plus B cos theta together, and another one is B sin theta. Now, what we are going to do is, we'll go for Pythagoras theorem, we'll calculate magnitude of R, and we'll get direction of R. But before that, how do I know that R is the resultant of A and B? Let's check. This is vector A, right? This is vector B. Why I have taken this vector B? Because I am saying parallelly you can shift this vector anywhere in the given plane. So it's okay even if I'll shift this vector over here, right? What the triangle of vector addition suggests? This is A and B, right? You have arranged them in an order. Then the resultant is a vector which starts from starting point of first to the end point of last. Right? So it's very obvious, resultant of A and B must be R. Why? Because triangle law of vector addition says that R is equal to A plus B. I hope everyone is agree with me. Right? Now I'll proceed with my task. What is my task now? It's calculation of R. I'll do it. Now everyone can calculate because it's simple calculation now. Right? Okay. Hypotenuse square. It's R square is equal to. What do you have here? A plus B cos theta whole square. I'll write it here. A plus B whole cos theta. A plus B cos theta whole square plus B sin theta whole square. Okay. We'll expand this. It's A square plus twice AB cos theta plus B square cos square theta plus B square sin square theta. Now look at the equation. What I'm going to do is, look at this equation and especially last two term. Is it okay if I'll take B square common from these two terms? Yes, definitely. Then what is remaining in the bracket? It's sin square plus cos square. Sin square theta plus cos square theta, it's 1. How come? It's a trigonometric identity, right? So what I'll do is, it's equal to A square plus twice AB cos theta plus B square is equal to R square. What is R now? It's a magnitude of resultant vector. I'll calculate it here. R is nothing but under root A square plus twice AB cos theta plus B square. Even you can rearrange this term. It's A square plus B square plus twice AB cos theta is equal to the resultant. I hope I'm done with the magnitude of this resultant. Yes. If I'll ask you to calculate the direction, then what is mean by direction first? You must have observed that in last session I explained about the direction of a vector. Either you write in terms of direction, it's like east, west, north, south, or that angle is making certain angle, that vector is making certain angle with the horizontal, right? So whenever someone will ask you to calculate the direction of vector, is nothing but you're supposed to calculate the angle made by that vector with the horizontal one. I'm gonna do the same thing here. So let's assume that angle made by resultant R with the horizontal is alpha. Now my another task is get direction. So I'll write it here, tan alpha is equal to. Again look at this big right angle triangle. It's opposite by hypotenuse. Opposite is B sin theta and adjacent is A plus B cos theta. So suppose if you have to calculate alpha, that is nothing but tan inverse of B sin theta divided by A plus B cos theta. Are you getting my point? Once again, magnitude of the resultant of two vectors is under root A square plus B square plus twice AB cos theta, whereas alpha means it's an angle made by that resultant with the horizontal. How much it is? Tan inverse of B sin theta divided by A plus B cos theta. Right? Let's say now you have given with two vectors. Let's say this is one vector and this is second vector and angle between them is known. Let's take one example. Let's say I have A is equal to 4 meter, I have B is equal to 5 meter and angle between them is equal to, let's say, 60 degree. Try to understand what I'm saying. I'm gonna use this rule or I'm gonna use this law. Which law I'm talking about? Parallelogram law of vector addition. What that parallelogram law of vector addition says, whenever two vectors are given and they start from the common point, then the resultant is their diagonal which starts from the same point, right? And how to calculate the magnitude of resultant? This way. Now, similarly, if I have two vectors, magnitude of one vector is 4 meter, magnitude of second vector is 5 meter, angle between them is 60 degree, then how to calculate the resultant? I'm going to just simply use that formula. What is the formula? R is equal to under root a square plus b square plus twice ab cos theta. What are the values given? It's 4 square plus b, it's 5 square plus 2 times a, it's 4, magnitude of b, it's 5 into cos 60. How much is cos 60? You must be aware about all the trigonometry's values, sin theta, cos theta, right? So how much is cos 60? It's half. So I'll be substituting here. It's 16 plus 25 plus cos 60 is half, and this half and 2 is getting cancelled. So how much I'm getting? 5 4s are 20, right? So now what should be the answer? It's 36, 36 plus 25. How much you get? 36 and it's 5 1 and 5 61. Again check the answers. Yes, it is root 61, right? So what should be the magnitude? It's root 61. Now, if I'll ask you to calculate the resultant means it's an angle made by the resultant with the horizontal, that is a direction. How to get the direction? Alpha is equal to tan inverse of, what is the value of B? B is 5 meter. I'll write it here. B is 5 meter into sine 60. How much is the sine 60? Sine 60 is nothing but root 3 by 2 divided by A plus, how much is A? It's 4 plus B cos theta. B is 5 into cos 60. Put the values, get the answer, right? So how will put the values? It's tan inverse of 5 sine 60 is root 3 by 2 divided by 4 plus 5 into half. Cos 60 is half. Just I'll be putting the values and I'll be able to calculate the resultant. I hope concept is clear to everyone. I have explained triangle of vector addition. With the help of triangle of vector addition, I won't be able to calculate the magnitude of resultant as well as the direction of resultant. So we'll proceed for the next law that I said, parallelogram law of vector addition, and I explained whole parallelogram law and how to apply that, right? So what equation you are getting for the parallelogram law? It's this. And what about the direction? Is this one. Now we'll go for some special cases of the parallelogram law of vector addition. A special condition. It's like, or I say special case. What are the special case? Let's say theta is equal to 0. We have two vectors A and B, but angle between them is 0. I have one vector A and I have another vector B, and angle between them is equal to 0. What I'm going to do is, again I'll recall the same equation. What is that equation? R is equal to under root A square plus B square plus twice AB cos theta. What is going to change now? Cos theta. Cos theta is how much? It's cos 0. Cos 0 is 1. So I'll put it in the equation. Let's say R is equal to A square plus B square plus twice AB cos 0. Cos 0 is 1. So what do you get here? It's A square plus B square plus twice AB. And you can see this expansion is very well known to you. This is nothing but A plus B to the whole square, right? A plus B to the whole square is nothing but A square plus B square plus twice AB, right? So instead of this, it's okay even if I write this, right? And square root is going to get cancelled. So how much R you get here? It's A plus B, right? Concept clear to everyone? Okay, now R is equal to A plus B if I am taking angle between them as 0. We'll go for another special case. Okay, I'll do one thing. I'll clear this. Okay, another special case is, let's say theta is equal to 180 degree, right? Again, I'm going to do the same thing. R is equal to under root A square plus B square plus twice AB cos 180. Cos 180 is minus 1. So what will be the equation then? A square plus B square minus twice AB. And you must be aware about this expansion again. This must be a minus b to the whole square, right? So I'll write it here, under root a minus b to the whole square. So how much you get? Square and root will get cancelled and r must be equal to a minus b. Look at here, one special case I used where angle between them is taken as 0 and I have calculated r is a plus b. If I look at this value, I am getting r is equal to a minus b. And suppose if I will go for third case, theta is equal to 90 degree, right? In that case, what will happen? Again, I am going to put cos 90. Cos 90 is 0. So, third term becomes 0. So, what should be the answer? R is equal to under root a square plus b square. If I will check all these three's value, one is r is equal to a plus b, one is r is equal to a minus b, and one is r is equal to under root a square plus b square. If I will check this value, you will come to know that this value must be the maximum value of resultant, right? And this value is minimum value of the vector addition. Try to understand what I am saying. I am saying a plus b is the possible maximum value of the vector addition, right? When I say r is equal to a minus b, this is the minimum possible value of the vector addition, and all the values will lie in between max to mean. Let's say I have two vectors, a is equal to I am taking 5 and b is equal to I am taking 7, right? And someone says that the resultant of these two or maximum value of let's say resultant of these two is equal to, let's say 15. Try to understand what I am saying. I have taken the example. I have taken two vectors. One is 5 and b is equal to 7, right? And what I am saying, given that resultant of these two vector is 15. If you will check this, r max is nothing but 5 plus 7, which is 12. So you should identify that sorry, there is no any possibility of resultant greater than 12, right? So this is not possible. So maximum value of resultant is equal to 12.